Hi, welcome back to another episode of Algebra in Words, the video series. In this video, we're going to start looking at absolute value equations. And in the next video, we're going to be looking at absolute value inequalities. But in this video, we're going to look at two types of absolute value equations. One in which there is one absolute value, and another type where there's two absolute value groups like this. Before we start, if you want to follow along what we're about to go over and the procedures and examples in written form, you can follow along with it in my book, Algebra in Words 2, starting on page 20. And you can find that on Amazon at the link in the description box below. So anyway, let's get started and talk about absolute value equations. So what are absolute value equations? Well, they're just equations that have absolute value groups in them. And a little quick background on absolute values, which you may or may not know, is that whatever you simplify inside an absolute value group to be, whether it's positive or negative, it automatically comes out as positive when you remove the absolute value bars. Also, a quick little side note is that if you're thinking about order of operations, an absolute value group qualifies as a group, meaning it would be the first thing that you would simplify in regards to order of operation. So let's get started. I have a few problems on the board, and I'm going to explain them as we go because there's not really much to it. There's a few little procedural steps involved, which I'll explain as we go. But before we do them, I'll give a quick overview of the steps involved in solving an absolute value equation. In short, you should expect to get a maximum of two answers. You could get one answer, and there are also situations where you could get no solution, and I'll make sure that I show an example for each. But basically what you have to remember is, when you have an absolute value equation like this, you're going to first start off by simplifying it as much as possible, meaning simplify inside the absolute value group first, as well as getting the equation so that the absolute value group is by itself on one side. Once you have those in order, then what you're going to do is, I call it splitting the equation up into two equations, the positive form and the negative form. And then you solve the positive form and the negative form separately, and you'll likely arrive at one solution for each, and those would represent the maximum of two solutions for your absolute value equations. So again, just to give a quick summary of what to expect by the end, you should expect to get two answers for an absolute value equation, but there are exceptions where you could get one answer or no solution. So I have three examples on the board, and let's get started. And I'll show you the procedure as we do it. So the first one we have is the absolute value of x equals 4. Now watch what I do here. I like to do this with arrows. One arrow like this, and I indicate that with a positive sign, and another arrow down here, which I like to show with a negative. Okay, now what does that mean? You have to follow this very specifically. And by the way, there are different ways to do this, but I'm going to show you one way, and I recommend that you follow this way and basically keep consistent, because if you keep consistent, it'll make it much easier for you. If there's another way you like, obviously, you can do it. I would check with your teacher to make sure that it's an acceptable way to do it. So here's what to do. Simplify as we talked about before, and this so far equation is as simplified as possible. We have the absolute value group on one side and everything else on the right. Now we split it up, a positive and a negative. What's the positive? The positive means start by taking what's in the absolute value group and take the bars off, so it's going to look like x equals, and for the positive form, leave whatever's on the right exactly as it is. So we're going to call it 4. Now what about for the negative form? You're again going to remove the absolute value bars and leave what's in it like this, x equals, but then you're going to multiply the entire right side by a negative sign. Okay, if it helps you, think of it as multiplying the negative through, think of it as multiplying it through a group, which is everything on the right. Now in this case, there's only a 4, so if you just said equal to negative 4, that's fine because 4 is not a group. Okay, so let's just quickly summarize what we did in this first equation because it's going to set the standard for what we do in the later equations, even though there might be a few more steps. We simplified as much as possible, got the group on one side by itself, then we split it up into a positive and a negative. In the positive, we left whatever was on the right completely as it is and solved. It already happens to be solved, x equals 4. For the negative, we ran a negative through the right side, and that made this 4 negative 4. So the answer to the other one is, if we just shorten it, x equals negative 4. So the answer to this equation is 4 and negative 4. Let's apply that method to the next equation. Now I chose this equation because this starts off not in simplified form. What's in the absolute value group is simplified, so there's nothing to do inside. However, the group is not alone to start. So we want to isolate it, and we're going to subtract 1 from both sides. Okay, and now let's write what that gives us. The absolute value of 5x equals, and 5 minus 1 is 4. Okay, so now, and I'm just going to erase this a little bit. I'll leave it there, but let's just focus on this equation. And now we're going to split it up into a positive and a negative. Let's put the positive up here. We're going to take off the absolute value bars and make it 5x equals, and now the positive form of this, which is itself, 4. And then we're going to do a negative form, which would be 5x equals negative 4. Run a negative through the right side, which would be negative 4. It's not the best that the first example and this example both use 4 because they kind of look the same, but it just happens to be coincidence. Alright, and now we're going to just continue to simplify each of these equations separately until we solve for x. So for the top one, let's squeeze in here, divide both sides by 5, the 5's cancel, and we're left with x equals 4/5. And for the bottom one, which is the negative form, again, divide both sides by coefficient 5. The 5's cancel, and it leaves us with x equals negative 4/5. And so the answers to this absolute value equation are 4/5 and negative 4/5. They're the two answers. And finally, that brings us to the last problem here, which is a little bit more complicated. And in this case, we have two absolute value groups, one on one side, one on the other side. Now, since there's already one on one side and one on the other side, there's not much you can do in terms of simplifying by putting one on one and one on the other side because they're already that way. But you would want to check inside each group to see if they can be simplified any further. And again, in this case, they're already in their most simplified form. So we're going to move on to the next step. Now, even though there's a second absolute value group in this equation compared to the previous examples, you're actually going to apply the exact same method. Okay? We're going to split this up into positive form. And down here, let's make sure we have a little room. The negative form. So I'm going to take the group symbols off of this on the left, and 2z plus 3 equals, and I'm going to do the positive form of this, which is just whatever is inside the group as is. So basically untouched, except remove the absolute value bars. 2 minus z. And now we're going to do the negative form in the below. Keep the front the same, remove the absolute value bars, so 2z plus 3 equals, and now you're going to remove the absolute value bars from the right side and run a negative through it, meaning it will change all the signs. So this will now be 2 becomes negative 2, and negative z becomes positive z. And all we're going to do for both of these equations is just solve and simplify and solve for x. So up top, suppose we want to get the z's on the left side, we would add z to both sides. And since we want to move the numbers and or constants to the opposite side, let's subtract both sides by 3. Two z plus z is 3z. Let me do that over here. So we can divide, and we'll do that in the next step. So 2z plus 1z is 3z equals, okay, and then 3 minus 3 cancel to 0. That's canceled to 0. Then on the right, 2 minus 3 is negative 1. And the negative z plus z cancel to 0, so that's gone. So we have 3z equals negative 1. And now let's divide both sides by coefficient 3. And we get z equals negative 1/3. So I'm just going to circle negative 1/3. And now let's solve the equation at the bottom for z again. Again, let's try to get the z's on the left. So let's subtract z from both sides in this case. And again, we're going to subtract 3 from both sides here. On the left, 2z minus z is 1z. Let's put that here as z. And 3 minus 3 cancels to 0. That's gone. Equals negative 2 minus 3 is negative 5. And z minus z cancels to 0, so that's gone. And it's already simplified. So in summary, this absolute value equation, which involves two absolute values groups, equals negative 1/3 and negative 5. To summarize the last equation, we started off with two absolute value groups, and we broke it up, a positive and a negative. We left the front part the same in both equations. But in the top one, or the positive form, we took what's inside the right group and just removed the bars and left it as is. However, for the negative equation, we took the bars off and multiplied a negative 1 throughout to change the signs of both. And then we simply solved each equation equal for x, or in this case z, and we got two answers, which is what we expect, and that's pretty much it. So I'm going to erase the board and put a few more problems on the board just to clarify this topic. Okay, I put two more absolute value equations on the board. They're somewhat simple, but these are meant to sort of make a couple points. Let's look at the top one. The absolute value of x equals 0. Now normally what I would tell you to do is to split this up into a positive form and a negative form, right? We could do that except for the fact that 0 does not have a positive and a negative form. It's just 0. So long story short, that means that whatever's inside here equals 0. Now what you technically should do is go through the steps and take what's inside the absolute value group, x, and set it equal to 0. And then solve. And we already know that the answer is going to be x equals 0. Now where this might be different is, suppose that there was a mini expression inside there besides x. Suppose it was like x minus 3. Well, then you would set x minus 3 equal to 0 and solve, and you would get x equals 3. But the bigger point here is that when an absolute value group equals 0, you would expect to get one solution. The one solution will not always be 0. It depends what's inside. In this case, it happened to be 0. But again, to reiterate, when you have an absolute value group set equal to 0, you expect one solution, and that's what we got here. Let's look at the next one. The absolute value of x is equal to negative 6. Now, if you remember just the basic principle of what makes an absolute value, it means that the value of what's inside the absolute value group must be positive when you remove the bars. Now, would it make sense that a positive quantity can equal a negative number? No, that simply doesn't make sense, and it's an inequality, and the way that you would answer this is no solution. Because there's no value for x that, when converted to positive, would equal a negative. Now, you might see a trick. It's not really a trick because it's a legitimate question, but you might be given a question like this to trick you. And what people normally do is they say, okay, well then I could say x equals negative 6. But that doesn't make sense because when you start with the absolute value of negative 6, it equals positive 6. And positive 6 doesn't equal negative 6. So again, the point to this problem is beware when an absolute value group equals a negative number to start. And when it does, there's no work to do. Just say no solution. So I'm going to erase these and put a couple more on the board. Okay, I have the last two problems on the board. Let's look at the top one. It has one absolute value group, but it's not isolated on one side. So we want to simplify this by moving the negative 2 to the right by adding 2 to both sides. We just brought down the absolute value group. Remember, that's an absolute value bar, not a 1. That's not 16. It's 6x equal 6 plus 2 on the right makes 8. And now we're going to split this up into the positive form and the negative form. Remember, we keep whatever's inside the same for both equations. 6x plus 2 and 6x plus 2. Now back to the top in the positive form, we're going to take what this is, which is 8, and leave it the same, which is 8. And then let's just complete what this equation will be, which would just be a negative through this, which is negative 8. Let's go back to the top and solve for x. Minus 2 minus 2, 6x equals 8 minus 2 is 6. Divide both sides by 6. And we get x equals 6 over 6 is 1. I'm going to circle that, but remember, we're going to still solve for the other solution. So now to the negative form equation, which we already have set up, we're just going to solve with normal algebra rules. Minus 2 minus 2, 6x is equal to negative 10. Divide both sides by coefficient 6. and negative 10 over 6. You can simplify that, divide a factor of 2 out of the top, which is 5, and a factor of 2 out of 6, which is 3. And so we get negative 5/3. And let's circle that. So the solutions to the first one are 1 and negative 5/3. We can leave it as an improper fraction. If you make it a decimal, that's probably fine. Okay, now let's go to the next one, which is two absolute value groups, one on each side. Check to see if it can be simplified, and there's nothing that can be simplified any further. So now we're going to set up the positive form and the negative form. And since we don't have much room over here, let's just do it below. So I'm going to do the plus form here and the minus form here, and we'll squeeze it in as best we can. Remember, for both of these, the left group is going to be kept the same after we take the absolute value bars off. 2x minus 1 and 2x minus 1. In the top will be the positive form, keeping what's in the right group the same. 2x plus 2. And in the bottom, we're going to run a negative through this group after we remove the bars, which will change the sign of each term. That will make it negative 2x minus 2. Let's solve the top one first. We want to get the x's on the left, and I can see where this is going already, it seems, but so let's add 1 to both sides, and since we would hypothetically want to move the 2x to the left, we would subtract 2x from both sides. Now, if you notice, we have 2x minus 2x, which equals 1. Let's put that over here. 1. It's actually 0 because the negative 1 plus 1 becomes 0. On the right side, these cancel to 0, and we have 2 plus 1, which is 3. And does 0 equal 3? No, so this portion makes no solution. We could just put a cross through that as no solution. Let's see what happens in the bottom, though. Let's add 2x to both sides, because on the right now this is negative. Okay, keep in mind this is just to show this is the negative form, so keep that separate from the number. So plus 2x, and we want to move the 1 to the right, so let's add 1 to both sides. 2x plus 2x is now 4x. Let me bring that over here. Equals, these two x's cancel to 0. Negative 2 plus 1 is negative 1. Divide both sides by coefficient 4. And what we get is x is equal to negative 1/4. And it just so happened that this equation happened to have one solution, and that's a possibility. There could be a maximum of 2 solutions, and if you took notice, the equations and the examples that we've done so far happen to be 1-degree expressions inside the absolute values. Had there been higher power or higher degree expressions, we could expect more solutions as well, possibly. But anyway, that concludes this video on the topic of absolute value equations. There could be the type with 1 absolute value group and the type with 2 absolute value groups. I hope that you can follow along in this video and use the consistent method despite which type you're given. And also remember that there could be 2 solutions, or 1 solution, or no solutions. So that concludes this video. I am going to continue this conversation and this topic of absolute value, but in the next video we're going to look at absolute value inequalities. See you in the next video.